This course is focusing on character lighting, one of the most common occurrences in VFX. Approaching your lighting step by step and getting the basics right are the most important aspects. And with basics, I mean matching the set data as close as possible to create a seamless integration and using film lighting rules to enhance your lighting. I often also take a look at how the DOP and/or the director works and what their lighting style is. Often a film has a certain lighting language, which if you are able to identify and incorporate, will help telling the story and help integrate your characters easier. Approaching environment lighting can be very different to character lighting. The most obvious difference is the scale. With environments, you usually deal with huge landscapes, cityscapes, or buildings. With environments, you often don't have much set photography to reference to. An important step when designing the lighting is finding appropriate references and artwork. Prototyping the environment in 2D or 2.5D by a concept artist is often way more efficient as well than trying to define the lighting and the look in 3D. On the technical side, the biggest challenges usually are detail, scale, and the amount of assets and geometry you have to handle within the renderer. Care has to be taken to optimize the renders as much as possible. From a purely technical aspect, dealing with crowds is quite similar to environments. Large amounts of geometry, a lot of assets, so optimizations, memory, and render time management is important. Spending time optimizing the crowd characters will be an important aspect of setting up and lighting the crowd. Similar to environments, your lighting can also not be too complicated. Often, I use nothing more than an HDRI and a key light. Working with gobos to break up the light, to simulate clouds, or just to create variation will be most of the time the main work. Crowds means lots of the same or similar characters, and part of the lighter's job can be to find ways to randomize the colors in the shaders per character a bit to avoid the crowd render to look repetitive. In traditional pipelines, effects like volumes, explosions, fog, dust, etc. are rendered usually by FX artists, and lighting TDs would just create interactive lights based on locators or low-res FX meshes for their assets. Often FX doesn't even use light rigs, but just creates red, green, and blue lights which comp can use as masks to brighten or darken the volumes in 2D as needed. This approach is slowly getting less and less common, with more efficient methods to pass volume data between departments and faster CPUs and more modern render technology. In newer pipelines, we are starting to not just render interactive lighting passes in 2D, but also the actual effects for better lighting integration. The ability to render everything in the same render engine can help downstream departments and often improves the look a lot. This avoids problems like motion blur, displacement, or geometry mismatches as well. This also means the lighting of the assets rendered in TD can be affected, for example, by the fog or smoke, and attenuate the lights in a more realistic way. And while FX renders usually are heavy and slow, especially 3D light is very efficient in the way it handles volumes and FX data. Feature animation has generally a very different approach in lighting. The mood in lighting is usually defined by an art director or concept artist, and this happens for the entire movie. Color keys and mood boards will give a guide to the lighting team to light their shots. Reality often gets bent to achieve the lighting necessary, and there are also less rules in terms of following physical, plausible lighting. But usually lighting still has to be believable for the viewer. In feature animation, there is also often a difference between shot TDs and lighters. Lighters concentrate on the creative aspects and actual lighting work, whereas the shot TDs take care of the shot assembly and debugging and optimizations.